16.8 grams of sodium hydrogen trioxocarbonate 4 is completely decomposed by 8. Calculate the volume of carbon 4 oxide given off at s.t.p. Atomic mass of sodium equals 23, carbon equals 12, oxygen equals 16, hydrogen equals 1, and the molar volume of a gas at s.t.p is equal to 22.4 dm3. Solution. Before we continue, if you are yet to subscribe to this channel, kindly do that and also click on the notification bell so as to be notified as soon as new videos are being released. And let's continue. Question above has to do with decomposition, and the compound involved here is sodium hydrogen trioxocarbonate 4. So the first thing we are going to do is to write out the chemical equation showing the decomposition of sodium hydrogen trioxocarbonate 4 by 8. So we have the chemical formula to be NaHCO3. When this decomposes, it gives off sodium carbonate, that's Na2CO3, plus carbon dioxide, CO2, with steam, that's H2O. Now the next thing to do is to check if we have a balanced chemical equation. Starting with sodium here, we have 1 present in the reactant side, and in the product side we have 2. So now we need 2 here to balance sodium. Meanwhile, this 2 is affecting every other element present in this compound. So for hydrogen now we now have 2 atoms present. Now checking here we have 2 as well. So hydrogen is balanced. For carbon we have 2. So in the product side we have 1 here plus 1, that makes it 2. Carbon is balanced. For oxygen we have 2 times 3, that's 6 in the reactant side, and in the product side we have 3 plus 2 plus 1, that's 6 also. So we have oxygen balanced. Now we have a balanced chemical equation. Let's proceed. Amidst all the compounds listed here, the one we'll be dealing with is just the substance that is being decomposed itself, that is sodium hydrogen trioxocarbonate 4, and the carbon 4 oxide gas that was given off. So now from this equation now we can state that we have 2 moles here, 2 moles of sodium hydrogen trioxocarbonate 4 giving off 1 mole of carbon 4 oxide. So this is the stoichiometric relationship between them, and it's 2 moles of sodium hydrogen trioxocarbonate 4 will give off 1 mole of carbon 4 oxide at s.t.p. And also at s.t.p, 1 mole of gas contains 22.4 dm3. Moving forward, from the question we have been given the mass of sodium hydrogen trioxocarbonate 4. Since we have been given the mass, we need to determine the reacting mass first of sodium hydrogen trioxocarbonate 4. For reacting mass, we need to calculate the molar mass of sodium hydrogen trioxocarbonate 4 first. So now for molar mass of NaHCO3, we have that to be equal to, that's the sum of the atomic mass of each element present, starting with sodium 23 plus hydrogen is 1 plus carbon 12 plus oxygen, which is 3 atoms present. So we have 3 times 16. 16 is the atomic mass of oxygen. So this gives 23 plus 1 plus 12 plus 48, which is equivalent to 84 grams per mole. Now reacting mass of NaHCO3. We are doing this so as to have a relationship between the 2 substances involved. To get the reacting mass of NaHCO3, we'll be multiplying the number of moles of NaHCO3 in the equation from the balanced chemical equation. We'll multiply that with that of the molar mass. So now reacting mass of NaHCO3 will then be 2 moles, and is the number of moles of NaHCO3 from the equation multiplied by the molar mass, which is 84 grams per mole. So this gives 168 grams. Now we've gotten the reacting mass of NaHCO3. Then we can now simply put that since 2 moles from this equation now, 2 moles of NaHCO3 is liberating 1 mole of CO2, that is carbon 4 oxide, at s.t.p. And also at s.t.p, 1 mole of gas contains 22.4 dm cube. With this, we can simply put that 168 grams of NaHCO3. Don't forget we are still working with this balanced equation. We give off 22.4 dm cube of CO2. I want to believe this is clear. This 22.4 dm cube is equivalent to the number of moles of carbon 4 oxide that is being liberated. So now we have 168 grams of NaCO3 to give 22.4 dm cube of CO2. What if we now have 16.8 grams according to the question? So now 16.8 grams of NaHCO3 we give off x dm cube of CO2. So from here, x will then be equal to 16.8 grams multiplied by 22.4 dm cube divided by 168 grams, which is equivalent to 376.32 for the numerator then the denominator remains 168 and our unit dm cube, which gives 2.24 dm cube. So this serves as the final answer, and this means that 16.8 grams of sodium hydrogen trioxocarbonate 4 will give off 2.24 dm cube of carbon 4 oxide at s.t.p. That will be all. Do not forget to subscribe and also click on the notification bell so as to get notified as soon as new videos are being released. Thank you. You can also leave your comments in the comment section.